All right, here we go. Let me finish this up. So we did, seems like forever ago, one sample t-test for means. And we do those if we do not know the standard deviation of the population, sigma. Or it could be, we looked at one example with a match pairs t-test, which is the same procedure where we were looking at the difference between the express lane time and the regular lane time. And so we're gonna look at one sample z-test for means here quickly. It says the lab is asked to evaluate a claim that the concentration of the active ingredient in a specimen is 0.86. They randomly select 30 analyses of the specimen. The mean result, we got an X bar, we've got a sigma, and it says, is there significant evidence at the 1% level that mu is not equal to 0.86? So let's define mu. It is the true mean concentration of the active ingredient. In the specimen. And I'm gonna write down some things that I know. So I've got X bar, 0.8404. My sample size is 30. And sigma is known to be 0.068. So my null hypothesis, I've got to have a mu in there because this is a one sample z-test for means. And it's a z-test again because I know the standard deviation of the population, which sometimes, many times you don't know that, but here's an example where we do. So I got mu equals 0.86, and my alternative is going to be mu is not equal to 0.86 because that was the given in the stem of the problem. Okay, so I'm going to check the assumptions, conditions. So we have a simple random sample of 30 analyses of the specimen. And the population of all specimens is greater than 10 times 30. Let's go with that. Check. Okay, so this is 10%. And my large counts, since this is a means, and n equals 30, I can say, what can I say? Why? Okay, because so trying to get you to say specifically, so the what applies? The central limit, that's it, okay? So the central limit theorem applies. So central limit theorem applies. Right, I'm gonna do the decision rule. So this is a z-test, so I've got a z critical value and a negative z critical value. And the reason I have this is because of my alternative hypothesis is not equal to, therefore it's two-sided. And alpha, let alpha equal 1%. And so that means I'm going to have 0.5% on this side and 0.5% on this side for my rejection regions. And so if you do inverse norm of 0.995, 0.1, you're going to get 2.576. So this would be 2.576, and this over here would be negative 2.576. And so I'm going to reject H naught if my p-value is less than alpha. And in this case, since I have two rejection regions, I'm going to say the absolute value of Z is greater than 2.576. So if my Z score is greater than 2.576, I will reject, or if it's less than negative 2.576, I will reject also. Okay, this is a one sample Z test for a population mean. And that's important. Need to put it that it's a mean because you can also have a one sample Z test for a population proportion. So Z equals X bar minus mu over sigma divided by the square root of it. And so I've got 0.8404 minus 0.86 divided by 0.068 divided by the square root of 30. And so now I'll take your calculator. And we are going to go the things on the outside, multiply by what on top. React that so they come to the board. And then take those X cubed in. What do I do with my 30? Next time. Maybe. There we go. Okay. So from the scratch pad, I'm going to go to menu, statistics, stat test, and then this is a one sample Z test for mean. So it's the first one there, Z test. And then I am going to input the data manually. So I'm going to choose stats. And so mu sub naught was 0.86. Sigma was 0.068. X bar was 0.8404. And N was 30. And I'm going to leave this as the default because it was a two-sided test, checking to see if it's not equal to it. All right, so I'm gonna hit OK. And it gives me my Z-score is negative 1.579, which is not less than negative 2.576. Therefore, my p-value is going to be 0.114. And so I'm going to fail to reject. No. All right. And so let me get back there. So this was negative 1.579. P-value is 0.114. And so since our p-value is greater than alpha, we fail to reject H0. So there is not sufficient statistical evidence to conclude the true mean concentration. Now we put it in context. So the true mean concentration of the active ingredient is not equal to 0.86. Must be in terms of the alternative hypothesis. Okay, now I'll do a 99% confidence interval. Does the hypothesized value fall in the interval? What's the answer to that? And how do you know? Well, did I reject H0 or fail to reject H0? We failed to reject, therefore 0.86 should be within my interval if I fail to reject. Okay, otherwise I did some math wrong. Okay, so yes, it's going to be in the interval because I failed to reject. So parameters are same as above. Assumptions are also same as above. And this is the name of this is, it's a 99% confidence interval. And why is it 99? Because look at my decision rule. Alpha is 1%. And it's a two-sided test based on my alternative hypothesis. So I've got 0.5% here and 0.5% here. Therefore, the middle has to be 99. Okay, so this is a 99% confidence interval, Z interval, for one sample mean. All right, and so that's going to be X bar plus or minus Z critical value. And then times sigma divided by the square root of it. Okay, so I'm going to plug those values in. 0.8404 plus or minus 2.576 times 0.068 divided by the square root of 30. And then I'm going to go to my calculator. And so we go to menu, statistics, confidence intervals. And this is a Z interval. And I'm going to input the stats. Sigma is 0.068. X bar was 0.8404. N is 30. And then make sure you change your confidence level to 0.99. Okay. And so I get a lower bound of 0.808 and an upper bound of 0.872. And notice that 0.86 is within the interval, which it should be because I failed to reject. So let me write this is 0.808 to 0.872. We could say, I am 99% confident the true mean concentration of these specimen is captured in the interval from 0.808 0.872. And since 0.86 is in the interval, this agrees with my significance test.